Okay, so yes, welcome to back to school. Stats 10, Introductory Statistics, or I think in the course catalog it says Introduction to Statistical Reasoning or something like that. This is our textbook here, but they don't sell this at the bookstore, right? It's like they sell you this chopped up paper version, something. Okay, well, so if you get the hardbound thing, that's great. If you buy the chopped up version, that's also fine. It's cheaper that way, but also your resale value is like totally small. So, you know, trade-offs, life is hard. You know, students were asking, can I use the first edition? Yeah, it should be fine, but the textbook numbers, problems might not line up. Do you need the MyStatLab stuff? No, you don't need that. We will use, did you guys get a clicker?
Not yet.
Not yet? Okay, so the department's pushing these, so we're gonna use these. It's, I've put up instructions on how to register this with your student ID, and I'll put questions up throughout the lecture, just kind of to test your understanding, and you'll get points that way, okay? So it's my first time using the clickers. I hope that it's worthwhile in terms of, you know, keeping you guys engaged in the lecture, and it's a way to earn you guys some points here. We'll take a quick look at the syllabus, okay? Oh, well, that's unfortunate. Oh, here we are. EduRoam. EduRoam is super awesome. If you guys don't use that, you can go to like other campuses around the nation, and a lot of them support EduRoam, and you get free Wi-Fi there. I guess it's a little bit moot these days, just because we all have 4G LTE on our cell phones and can Wi-Fi hotspot ourselves. But 2 years ago, it was totally awesome. So. Okay, let's see. So here's our the syllabus. So I was trying to figure out a good grade scheme, and this is what I've settled upon. So in discussion section, which you guys will have on Thursdays, I will have some quizzes on these weeks. Okay, and these will be like 30-minute quizzes. And you'll do the quiz in discussion section, and then you'll go over the answers after the quiz is over. And I found that, you know, little incremental quizzes like this at frequent updates have helped in students keeping up with the content of the course and whatnot. Okay. That's cool, I guess. So those are, we'll have quizzes in discussion section. We'll also have two tests. So you can think of these as midterms, but they're not really midterms. They're worth only 15%, and they'll be in class here on these selected days. You will have a final exam. That's the big 3-hour test at the end of the quarter. And I believe this is our final exam scheduled time. On Tuesdays, you guys have lab. So were you guys able to get logged in and everything in lab yesterday? So starting next week, we'll have a lab assignment, and those will go through. Okay. I have 5% quote-unquote homework. So on CCLE, I'll have homework problems listed from the textbook. I'm not actually going to collect homework, all right? the homework is assigned for you to do and learn from. I will put the homework problems up. I'll also try to put solutions up for all of the homework problems I assign. But they're there for you to learn, to do and learn, okay? Don't just read the solutions and say, I understand it, okay? Because there's a lot of learning that happens when you try the problem and you got to figure out the answer for yourself, okay? But that said, I am not collecting the homework, and so it's possible for you to get through the class without having done a single homework problem. I have a feeling if you do that, you probably won't do as well on the quizzes or tests. So, so please do the homework problems. You know, the quizzes that we have in discussion section will probably be based heavily on the homework. So if you've done the homework, you'll probably be well prepared for those quizzes, okay? And so at the end of the quarter, I'm just going to give everybody 100% for their homework portion of the grade, okay? So it only counts 5%, but that's a free 5% for everybody, right? So is that cool? Okay, and we're going to do the homework, right? We're not going to just say, oh yeah, this is great. This is the class I don't have any homework in. And then get the clicker, and you get 5% clicker participation. And so if you add up these numbers, it adds up to 105%, okay? And so, so that's nice, right? Meaning you can get over 100%. So yeah, you know, if like, I don't know, you're not willing to buy the clicker, you'll miss out on your basically free 5 points, okay? So you know, get the clicker and then come to class, push the buttons. You know, you'll get more points if you answer them correctly, right? So I'll have questions, and there's like I don't know, this box calculates like who's here by pushing the buttons. So you'll get like a participation point for just coming to class and pushing the button when you're supposed to. But if you answer the question correctly, you'll get more points, okay? And so, does anyone actually have one of these clickers? Okay, and does it look like this? What does your clicker look like? Can someone hold up their clicker? Does that look different from mine? It looks similar. Yeah, okay. Well, and it's registered. Did you guys get it registered? I put up a little video on like how to register it, because I had just a little confused myself with my own thing. So so I registered my clicker, and you know, I used the roster with your student ID. So your 9-digit student ID, no dashes, to register, and then the thing says it'll synchronize and then give you points for your thing. So this is my first time using the clicker machine. So just bear with me, as you know, I'm sure every time we try some new technology out, there's a little bit of few kinks in the road. So probably maybe by 3rd week, I'll start using the clicker feature more heavily in lecture. Okay, are there any questions? Yes. Yeah, I don't. So you. Well, okay. So the lab manual, I went into the bookstore and I was like, "What? You guys have to pay $6 for like 10 photocopies?" I don't know. Okay, I guess don't keep this off the record here. I'm like recording myself as I'm doing this. I think I can post the labs onto CCLE and you can print them out yourself, okay? Now, that's assuming you have access to a printer. Maybe if you don't have access to a printer, you just spend the $6 and have them all ready for you, or I guess you don't even have to print it out. Things are just going to be done digitally. So I'll try to post the lab online. I hope I don't get in trouble for that. So don't tell on me for saying you can skip the lab manual. So, all right, is that all right? Okay. Wow, now I'm like nervous that I just told you that. Okay. All right. Oh, and you need a calculator for this class. Okay. So I'm assuming you guys all have a calculator from life, and but you can't use your cell phone as a calculator. All right. That's just like the rule, right? Okay. My email address is mileschen@gmail.com. When you send me an email, make sure you put somewhere in there stats 10, okay? Because I teach 4 statistics classes, and so if you say I'm in your stats class, I'm gonna have no idea what you're talking about, because it's like all of the classes I teach are stats classes, and I teach a stats 10 for extension, and that's XL10. So, you know, you got to differentiate yourself there, just because things are, you know, different between classes. So make sure your email says that you're in Stats 10. Okay, are we good here? All right, this is, I'm really excited. This is my favorite class to teach. This was my favorite class to take as an undergraduate student. I didn't come to UCLA, but the intro stats class that I took as an undergraduate student literally changed my life. I was an engineering major. I finished my engineering degree in undergrad, but then after working for a couple of years, I decided to come back to graduate school and study statistics because I loved my intro stats class so much. And I took several more stats classes in undergrad. And so, who knows, maybe you will like statistics a lot, and maybe not. You know, not everyone here is going to become a stats major. Some of you might choose to major or minor in statistics after taking this class, and if you do decide that, please, and if I was a positive contributing factor in that decision, let the statistics department know that that's the case. And if I was a negative factor, don't tell them that. But yeah, and so here I am. So I finished my PhD in statistics here at UCLA earlier in 2015, and I landed my dream job of teaching statistics here at UCLA, best university ever, and teaching the best class ever. So I'm just really excited. So I hope you enjoy the course. I hope you guys give me positive reviews, as those reviews are very important as early on in my career as a lecturer here. So anyway, are we excited for this class now? Yeah. All right. Yeah. I'm excited. Okay, so let's talk about statistics. Okay. All right, so what is statistics? What is statistics? Why do we study statistics? I guess I don't need to pause if I'm asking rhetorical questions. We study statistics because it helps us understand the world around us. Okay, why do we study statistics? Well, this is what I argue, that we come to university and study any subject really worth studying is you know, to help us understand the world around us, and in particular, statistics allow us to make conclusions from limited data, okay? And it's a systematic way to make conclusions from limited data. Because really, all of our decision making, well, almost all of our decision making is based on limited data, right? You know, should I break up with someone? You know, you have to take into account what is going on. You can't tell what's going to happen into the future. And you have to make a decision based on limited information. You don't know what the future holds. You don't know everything that's going to happen in life. And so your decision to, you know, break up or not break up is based on limited information, okay? Now, this class probably won't really help in answering that kind of question, but the statistics allow us this concept of using limited data to make a conclusion about the larger body, okay? And so we oftentimes we have a research question. Okay. And a research question, or we can think of this as a statistical question. Okay. This is a question that pertains to a population, okay? Pertains to a population or a group of subjects or people. Okay. So an example of a statistical question could be you know, what percentage of U.S. voters like candidate XYZ? Okay, so, you know, it's 2016, presidential elections coming up, and maybe I should, instead of saying voters like, we should say voters, maybe support is a better, more specific word, okay? So what percentage of U.S. voters support candidate XYZ? You know, it's like you ask, who are you going to vote for type of question, okay? And the only way we know, the only way we're going to know the true answer to this question is on election day, okay? Or if the candidate is not, you know, didn't make it to the general election, then you know, at these primaries type of thing, okay? We prior to election day, different organizations have polls, but the polls do not ask all U.S. voters, right? Okay. And so, you know, when you read the news and it talks about the latest poll results, those are all based on limited data, okay? They didn't survey all, however, millions of voters there are, but just a select sample, okay? So we have a research question, a question that pertains, okay? And to answer this question, we would need to survey all US voters and ask which candidate they support. Okay, this would require a lot of time and energy, and is probably, from a practical perspective, impossible to do. Okay. Except on election day. All right. And so instead of trying to survey everyone, we can survey just a sample of voters. Okay. Can I flip to the next slide? Okay, so this thing represents our population. Okay, and in our case, this would be all US voters. Okay, this thing is too big to study directly. And so what we do is we just take a little piece out of the population, okay, and this is called a sample. Maybe this is 900 US voters. Okay? And so what we do is we study the sample. Okay? And based on what we see in the sample, we can then make conclusions about the population. And so in order for the conclusions we make about the population in order for those conclusions to be valid, the sample that we have selected must be representative of the population. Okay? So if I select 900 people from UCLA, the answers we get will not be representative of US voters, okay? Because this demographic of young people at UCLA, it's going to skew much more liberal than the rest of the nation, okay? Now, of course, not everyone at UCLA is liberal. You've got a variety of people, but overall, just speaking in general terms of the students at UCLA, you know, comparing UCLA to, you know, someplace like Utah or Texas, the opinions about the political candidates or things like that, different topics, will be very different. Okay, and so in order for the conclusions from the sample to apply to the population, our sample needs to be representative of the population, okay? So, conclusions based on the sample our sample must be representative of the population, okay? And so this topic of getting representative samples is the focus of sampling methods. Okay, and there are, I guess I should ask, are you guys able to read my handwriting up on the board? This is okay? Yes, okay. We're good, all right. Is the focus of sampling methods, and so we'll talk about some of these sampling methods later on in the course, okay? But this is where we are headed, and there's a bunch of background that we have to talk about in terms of the types of conclusions we can make based on a sample. But I would argue that this is kind of the big picture, the main idea behind statistics is that you've got questions, a question about a big group that we cannot observe directly. And based on, and instead of trying to study everyone directly, we study a sample, and based on what we see in the sample, we try to make conclusions about the population, okay? And so this can be, applied to medical research. Maybe you want to know, is a drug, an experimental drug, effective at treating cancer? Okay. The population that we would want to study would then be every single person that this drug can be applied to, okay, or given to, administered to. So probably anybody with a certain kind of cancer would count as someone in the population. We obviously don't have access to every single person who has cancer. And so when people do clinical studies and trials, they're taking, maybe they do have 200 patients volunteer for experimental treatment. They see how the drug works in these 200 people, okay? And maybe, if they're lucky, it's like effective in all 200 people, and then there's no question this drug is effective, okay? But maybe it's effective in 10% out of those 200 people. And the question now is, well, does that mean the drug is working? Or could these 10% of people who got better, could that just have been people who are going to get better anyway? Okay? And we have all these questions to answer that are not very clear cut, and so we study probability to see how likely certain events are. We study descriptive statistics to be able to kind of summarize the results of our findings, and we're going to kind of compare our understanding of probability and our understanding of the descriptive statistics to make a decision about what we see in a certain experiment, to see if that then speaks to something about the general population. Okay? All right. How's this feeling? Okay? All right, so we'll talk just a little bit about stuff. You've got section 1.2, which is about storing data. Okay, and the big thing here is you've got numeric data, also called quantitative data. And you have categorical data. And this is also called qualitative data. Okay. Numeric data, this measures a quantity or how much or how many. They tell us how much or how many. Whereas a categorical data tell us what type or what kind. Okay. So I'll give you a few exercises in your homework this week that go over kind of the difference between numeric and categorical data, and then it will talk about creating a frequency table for categorical data. I think it's very straightforward that you can kind of read through it and get the hang of it. But just a quick check. If we were to go around and gather data on people in this classroom, and we ask things like, what is your gender? That would be categorical data, right? Okay. If we ask, how old are you? How many years old are you? Numeric. Okay. What would number of siblings be? Numeric. Number of siblings would be numeric. What about your area code? Area code would be categorical, okay? It's a number, but it doesn't answer the question of how much or how many, okay? So you can't say, I have 55 more area code than you. That does not make sense, okay? You can say I have 2 more siblings than you do, or I am 3 inches shorter than you. But to make comparisons between area code and say I have 506 more area code than you, haha, that's not a useful statement, okay? So just because it has a number doesn't necessarily mean it is numeric here, okay? So anyway, do your exercises that emphasize kind of go over numeric and categorical data. I think it's straightforward. Here, let me just double check here. So I'm going to make a summary table. This is called a frequency table. And so let's say we went around the classroom and and we did, what's your name and, your sex. And so we have, Joe, male, and Jenny, female, or whatever, okay? Blah, 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 ending with Pat, who is going to be a male. Okay, and so we're going to summarize this. And making up numbers here. Okay, so let's say this is what we have here. Okay, what kind of data is summarized in our frequency table? Okay, so is this numeric or categorical data? It's categorical data, right? We've got genders, male and female, okay? So there are numbers here, but it's categorical data, okay? Don't, right? Sex is categorical. Well, maybe it's more complicated than that, but just for simplicity's sake, we'll say everyone identified as male or female, and we'll leave it at that. Okay. Is that okay? Okay, so now I'm gonna get into, so I'm just gonna try to, like, today's lecture I'm gonna just kind of blitz through chapter 1, and I think that's okay. There's a few key concepts that I want to cover, but I think, take a look at your homework this week, or for chapter 1, and work through them, and I think we'll be in good shape here. If at any time I'm covering a topic way too quickly, or it's not settling in, or it's giving you trouble, just let me know, okay? And I can readjust and give more attention and focus to certain topics that need to. But I feel like chapter 1 is straightforward enough that we can kind of fly through, and I'll highlight the key points and leave it for you to do your reading to fill in the rest of the details. Okay, so in section 1.4 we talk about the differences between observational studies versus experiments versus anecdotes. Okay? And so what we say is that with anecdotes, these are the stories that people say, like, oh, I was suffering this thing, and then I called the help hotline, and they fixed my problems. And we're not discrediting what has happened in an anecdote, but as far as the statistical value goes, there's not much from a statistical perspective that we can do with anecdotes, okay? Because anecdotes are not, the people that share anecdotes, those are not representative samples of the population. So there's just not much we can do with anecdotes as far as from a statistical standpoint, okay? And I don't want to say like your story is invalid. That's not what we're saying. We're just saying from a statistical perspective, we can't do anything with anecdotes. Okay. However, if we have observational studies and experiments, we can make conclusions. We can apply the principles of statistics. Okay, so we can apply statistical principles to data coming from observational studies and experiments. Okay, and my hope is that at the end of this course, you will at least feel comfortable with being able to ask questions about some study that you might have seen, or an experiment that might have been conducted, and then you can then ask these kind of critical thinking questions about what kind of conclusions can be drawn from these studies or experiments. Okay, so in an observational study, we only observe the subjects. Okay, subjects end up picking their own kind of set of conditions or treatments. Okay, subjects choose their conditions or treatments themselves. Okay, we don't force treatments onto people in an observational study. We just let people live their lives and we see what happens. At the end of an observational study, we might see an association between one particular set of behaviors and a particular outcome. Okay? Okay? And all we can say is that these things are associated. We cannot say that one causes the other, or even one is, increases the risk of another. Okay? We can only say that they are associated. We cannot say that one causes the other. Okay, so for example, there was a study, a real study with real data, and what it said was that people who drink diet soda were had a higher risk, or people who drank diet soda experienced heart attacks at a much greater rate than those who did not drink diet soda. Okay, so different, and this was going around on Facebook and stuff, and people, different places were saying like, oh, see, diet soda is terrible for you. It's going to cause you to have heart attacks. That's not true. What's going on? Why would we see people who drink diet soda experience heart attacks at a higher rate than those who don't drink diet soda? Okay. Yeah, we got it.
They probably have like a different lifestyle.
Yeah, so just take all of these terrible stereotypes in your brain and think of, who might drink diet soda, okay? And think of someone who says, I will never drink diet soda, or something like that, okay? They probably look a little different in your head, right? Okay? And so in general, and this is, and it only takes just pockets of people to kind of produce these types of results, okay? If we think of people who are at risk for heart attacks, so maybe those who are overweight to begin with, they are probably more likely to be drinking diet soda than someone who is, let's just say a health nut, right? So they're, into fitness and into eating healthy. People who are into fitness and eating healthy are less likely to drink diet soda or even soda to begin with. And so, because we're not forcing people to drink diet soda and we're not telling people how to live their lives, there's just certain behaviors and certain outcomes might be associated. So So we cannot say that one causes the other. Is that all right? Okay. With an experiment, on the other hand, and this will be our last slide for the day. With experiments, the researcher, okay, assigns treatments to the participants. Okay, and ideally, all conditions are identical for all participants, except for the treatment. Okay. And then so at the end of the study, okay, if we observe a difference between this group and this group in the outcome, let's say, this group over here, we forced them to drink diet soda, and this group over here, we forced them not to drink diet soda, and then we saw if there was a difference in the incidence of heart attacks. Okay, and if we observe a difference in the incidence of heart attacks between these two groups, and everything else about these people's lives were exactly the same, which is not possible from a practical standpoint, but let's say we were somehow able to make sure everybody had everything else about their diets were the same, everything else about the amount of exercise they were getting was the same, everything else about the amount of sleep they were getting was the same, everything else about the amount of stress and the love that they experienced in their life. We made everything exactly the same for everyone, and the only difference was that this group was forced to drink diet soda, this group was forced not to drink diet soda. If we observe a difference, then the difference in heart attack incidence or whatever else might be can be attributed to the fact that this group drank diet soda and this group did not. Okay? Whereas, everything else, and that's because we controlled everything. So at the end of the study, any difference observed between groups can be attributed to the difference in treatments. Okay, and so with experiments, we can make cause and effect conclusions with, or I guess I should say with properly done experiments where the data supports such a conclusion, okay, we can make cause and effect conclusions. Okay, and we have all sorts of tools. We try to do blinding, and we also use placebos. These are used to help the set of conditions be identical for all of our participants. Because we don't want the participants to even know which treatment they're getting, because that would create a different set of conditions. If this group knows that they're getting this treatment and this other group knows they're getting the other treatment, then just that knowledge creates a different set of conditions. So by blinding or using placebos, we are trying to create identical sets of conditions there. Okay, so that basically just rips through chapter 1 there. So also take a look at the kind of the exercise that I've assigned for this week's homework, and we'll see you guys on Friday.